today's rapidly evolving world, organizations in both the government and private sector alike rely on technology and innovation to facilitate their operation and administration. King Mongkut's University of Technology North Bangkok is recognized as Thailand's leading
Innovation and Manufacturing, or RAM 26. I am Pempicha Plachat Davis, or in short, Honey. I am grateful and honored to be your MC for the morning session. Distinguished guests, ladies and gentlemen, before we officially open the conference, we would like to pay tribute in remembrance of Her Majesty Queen Sirikit, the Queen Mother of Thailand. Her Majesty's lifelong service, compassion, and commitment to the well-being of Thai people remain an enduring inspiration. We kindly request everyone to observe a moment of silence in her honor, please. Please rise for the moment of silence, please. Thank you. Thank you very much, and please be seated. On this memorable occasion, we are very happy to telecast the 67th anniversary video of our prestigious King Mongkut University of Technology, North Bangkok. Please enjoy our 67th anniversary of KMUTNB. While we wait for the video, today it's our remarks of establishment of the King Mongkut University of Technology, North Bangkok, and we all have the event the whole day from the morning session. So for today, the event at this very room, some of our executive board and our president would not be joining us today because we have other events around the university. And also every campus for us, KMUTNB has 3 campuses. The main one is the Bangkok one, and the smaller one is in Prachinburi province and in Rayong province. So the video will be the overall from the start of the university until our recent achievement of the years and 67 years that we established. And after the video presentation of the university will be the video presentation of the KMUTNB Techno Park later. The International Conference RAM 26 also is a part of our memorable day today. Yes.
Providing educational services, producing KMUTNB's 66th anniversary, an innovative leader embracing strengths for Thai economic growth. King Mongkut University of Technology North Bangkok, or KMUTNB, is an innovative university with a set of roles and responsibilities, such as fostering the advancement of research and technological progress, providing educational services, producing potential graduates for the manufacturing sector, being driving forces behind economic growth, committed to excellence in research and academic services, as well as delivering essential services to the private sector. KMUTNB was founded on February the 19th, 1959. It arose from the technical and economic cooperation between the Thai and German governments. Initially, the institution was called North Bangkok Technical School. Its educational approach was based on an aspect of German higher education, a combination of rigorous academic learning and hands-on experience. The then technical school became widely recognized and unofficially known as Thai-German Technical School. Later, it was transformed from a vocational school to a full-fledged academic institution. His Majesty the late King Rama IX graciously granted the university a permission to use the royal seal, the great crown of victory of His Majesty King Mongkut or Rama IV as the institution emblem. The auspicious name of His Majesty King Mongkut was also granted as the official name of the university. Currently, KMUTNB is a state autonomous university which offers a variety of qualification levels, ranging from the vocational certificate to doctoral qualifications. Prachinburi Campus. Rayong Campus. Six academic service units. Educational support units. KMUTNB has cultivated open-mindedness while actively pursuing diverse ideas and perspectives. The university has maintained its networks and collaborative partnerships across industries and private sectors. KMUTNB performs multiple roles, such as offering quality academic services, enabling continuous improvement in R&D, committed to sustainability concepts toward a green university, as well as implementing good governance, which nurtures workplace transparency and accountability. These attempts have improved overall corporate performance. So far, KMUTNB has achieved national and global acknowledgements through prestigious awards and recognitions. In commemoration of the 66 years of pride and accomplishment, KMUTNB's purposeful goals and priorities have been set to navigate our journeys. Institutional intentions involve curriculum enrichment to enhance learning. Producing the most employable graduates responsive to the needs of manufacturing and private sectors. Internationalization of R&D activities, as well as nurturing a dynamic culture of innovation which leads to the potential driving forces behind Thai economic growth and a formidable power to help Thailand secure its place among the leaders of technologically advanced nations.
Thank you very much, and we apologize. As mentioned, it would be 67 year of the anniversary, but I heard from organization team that it will be the surprise. So every one of you will have to join us for the banquet evening to see the video of the 67 years anniversary. So we apologize for the older one. So we hope to see all for the evening session. And the next is the video presentation of the KMUTNB Techno Park. Please enjoy.
In today's rapidly evolving world, organizations in both the government and private sector alike rely on technology and innovation to facilitate their operation and administration. King Mongkut's University of Technology North Bangkok is recognized as Thailand's leading university in science, technology, and innovation with worldwide reputation. Named after His Majesty King Mongkut or King Rama IV, who was recognized as Thailand's pioneer in the pursuit of science and technology. The university was also bestowed with the royal seal of King Mongkut by King Rama IX, the university's emblem. At KMUTNB, we are firmly committed to cultivating a culture of learning and everlasting development, which encourages innovation and enables our personnel to produce exceptional work, leading to greater innovation. Our leadership team has been dedicated to supporting our staff, turning a vision into reality, and implementing strategy for our university's growth. This commitment leads to the establishment of KMUTNB Techno Park to serve as a platform dedicated to bringing groundbreaking ideas to life. KMUTNB Techno Park is a division under King Mongkut's University of Technology North Bangkok, serving as a one-stop service for coordinating academic services. It focuses on the utilization of high-level research in the specific areas of university's expertise for the development of innovations that can be commercialized by industries. KMUTNB Techno Park also aims to foster collaborative through development of industrial alliances, encouraging partnerships between educational institutions and partners in both public and private sectors. Furthermore, it promotes the collaboration in various disciplines of universities' expertise and fosters greater link with the industrial sector, thus enabling more effective multi-stakeholder partnership. KMUTNB Techno Park is a network of collaborations located across KMUTNB's 3 campuses in 3 key provinces of Thailand. KMUTNB Techno Park at the main campus in Bangkok houses 1 institute, International Institute of Space Technology for Economic Development, and 5 cluster task forces which comprise of KMUTNB Techno Park at Prajinburi campus consists of 4 centers. KMUTNB Techno Park at Rayong campus is strategically located at the heart of Thailand's leading industrial zone on the eastern coast of the country. The main Rayong campus at Ban Khai district is home to, and the satellite campus at Map Taput KMUTNB Techno Park's Intellectual Property Service and Startup Alliance Acceleration Center has been established with mission to support and promote research utilization and commercialization. This division comprises of Technology Licensing Office and University Business Incubator. The KMUTNB Techno Park strives to be at the forefront of innovation and knowledge creation. Its objective is to generate value in the modern eco-friendly economy, while also advocating for sustainable societal development. This aligns with our university's mission and vision to lead advanced research, foster commercial innovation, provide academic services to society, enhance industrial sector, and nurture future human capital, all for greater mutual benefits of global community.
Thank you very much. And for the first agenda, it is a great pleasure to welcome Principal Research Scientist and Associate Professor Dr. Sanjay Mavenkar Rangkappa, the conference chair, to deliver the opening speech, please.
Respected Professor Dr. Tiruti Bonesopon, Chairman of KMUTNB, respected Professor Dr. Thanin Silpacharu, President of KMUTNB, respected Professor Dr. Ing Abel Sucha Singh Chin, former President of KMUTNB and Director of KMUTNB Techno Park, and also advisor to the President of Industrial Research Promotion and International Affairs, and also honorary chair of RAM 26. Distinguished KMUTNB administrators, distinguished speakers and guests, conference committee members, colleagues, participants, ladies and gentlemen, a very good morning to one and all. It is my great honor and privilege as a conference chair to warmly welcome you all to International Conference on Robotics, Automation and Manufacturing RAM 26. I am delighted to see such an outstanding gathering of researchers, industrial professionals, and academic experts from around the world, united by a shared commitment to advancing innovation and technology. This conference serves as an important global platform for exchanging knowledge and discussing recent developments in robotics, automation, intelligent manufacturing, artificial intelligence, advanced materials, and sustainable technologies. The strong participation from the academia and industrial reflects our collective vision to address emerging challenges and create impactful solutions for the future of engineering and industrial transformation. RAM 26 also highlights the importance of industrial collaboration, international collaboration, bringing together diverse perspectives that foster innovation, strengthen research participants and partnerships, and promote sustainable technological development. I encourage all the participants to actively engage in discussion, share ideas, and build meaningful collaboration throughout this conference. I would like to express my sincere gratitude to our KMUTNB management and administration, our keynote speakers, distinguished guests, organizing committee members, sponsors, and all the contributors whose dedication had made this conference possible. I wish you all a proactive and inspiring conference experience. Thank you one and all. Saudi Krab.
Thank you very much, Dr. Sanjay, for the opening speech. Now I feel immense pleasure in welcoming our beloved chairman of KMUTNB Council Committee, Professor Dr. Theravut Bunyasopon, for delivering an opening remarks, please.
Distinguished guests, ladies and gentlemen, it is a great honor to give an opening remark for this esteemed conference on our university 67th founding anniversary. Today, we gather to open the RAM 26 organized by KMUTNB. As we know, this conference is the good platform for researchers and industry professionals from around the world to discuss the latest development of robotics, automation, manufacturing technologies, as well as sustainable innovation, renewable energy, and eco-friendly materials. This conference will be one of the platforms for Thailand and also globally to extend their collaboration in research, innovation, and technology development towards sustainable development goals. With the vision of KMUTNB's invention to innovation as we embark on this journey, I encourage all participants to engage actively and embrace the opportunity to connect with one another. Let us inspire each other, challenge and perspective, and work collaboratively towards invention to innovation. In closing, I would like to thank to the distinguished speakers and participants from around the world and our conference committee members for their hard work in organizing this international conference and entire KMUTNB fraternity. I extend my heartfelt thanks to all of you for being here and for your commitment to advancing knowledge and innovation. Let us have an inspiring conference this morning, and during you stay here in our university and Thailand, if you have any problem with the police, please feel free to call me 24 hours. Thank you for your kind attention. Thank you very much.
Thank you very much to Professor for the opening remarks. In this occasion, we would like to mention for Professor Dr. Thanin Sincharu, the President of KMUTNB. He is a distinguished academic leader and researcher known for his contributions to engineering education, industrial management, and technological innovation. Under his leadership, KMUTNB continues to strengthen international collaborations and advance research excellence in science and engineering. Due to his obligations on this 67th anniversary day, he is unable to deliver his remarks or join us for the RAM 26, but he gave his best regards for the conference. Therefore now, I am very happy to invite the honorary chair of this conference, Professor Dr. Ing Habilitation Suchat Sieng Chin, for delivering the welcome address. The professor was our former president of KMUTNB, and currently its director of KMUTNB Techno Park, and advisor to the president for industrial research promotion and international affairs of KMUTNB. Please welcome Professor Sieng Chin for the welcome speech, please.
Dear Professor Dr. Tirut Bunyasopon, the chairman of the KMUTNB, and Professor Dr. Thanin Sincharu, the president of KMUTNB, and all management team of King Mongkut University of North Bangkok, distinguished KMUTNB administrators, conference committee members, distinguished guests, ladies and gentlemen, and all researcher team, everyone. Good morning. It's my great honor and pleasure to welcome all of you to the International Conference on Robotic Automation Manufacturing, or what we call RAM 26, and also the 67th founding anniversary of the KMUTNB University of Technology North Bangkok, which we plan to celebrate it all together for the dinner tonight. And on behalf of King Mongkut University of North Bangkok and all partners at the Techno Park, I extend a warm greetings to every participant joining us former across the globe. Personally, I will welcome the distinguished speakers, Professor Dr. Ing Habilitiet Lothar Kohl from Chemnitz University of Technology in Germany, and Professor Dr. Lennart Habilitiet Stefan Fischer from Dresden University of Technology in Germany, and Professor Dr. Ahmed Atimot Fauti from UTM Malaysia, and Dr. Siripong Pothalak from Toyota Motor Thailand Limited, Thailand, and my college assistant, Professor Nopadon Panchun from iLab team at the KMUTNB, and Dr. Ing Marcus Clay from Arlen University in Germany, who will give the online speaker in the part of the afternoon, and Dr. Sally Ganesh Totempudi from German University of Digital Science in Germany also will give the speaking online, and Professor Dr. Hiroshi Fukuda from Chitose Institute of Science and Technology in Japan. And today is our 67th founding anniversary of the King Mongkut University of North Bangkok. It means it is a 67 years relationship between King Mongkut University of North Bangkok and German cooperation. As well as know that the KMUTNB as established with the Thai-German cooperation beginning with the Thai-German Technical School in 1959, which laid the foundation of the KMUTNB, and all Silinton International Thai-German Graduate School of Engineering or TGS established through the bilateral partnership between KMUTNB and RWTH Aachen University in Germany in 1996 showed the deep this cooperation. This institution introduces the German model of industry-oriented engineer education in Southeast Asia. TGS has a MOU with the German partners, universities, double degree programs, and joint research initiative and long-term cooperation framework that have produced a sustained number of graduate engineers and researchers. Throughout this relationship, we have worked out closely with many German institutions, including TU Chemnitz and Merck Research Cluster, to promote the research which reflect or share commitment to the innovation for industry and environment. I would like to warmly acknowledge our German speaker, including our distinguished speaker mentioned earlier, and my friends, Professor Dr. Thomas Unwert from Chemnitz University of Technology in Germany, and Professor Dr. Tenorio Kuberti from Dresden University of Germany, and also Professor Dr. Jonas Hensel from Chemnitz University of Technology in Germany, and also Professor Dr. Sebastian Scholz from University of Applied Science, Zittau in Germany, and my good friends, Maximilian Kohl from Chemnitz University of Technology in Germany, and also Professor Dr. Supawadi Alawit from Chulalongkorn University. And looking forward, the present scenario today, this conference mainly focuses on the advancements in robotics, automation, artificial intelligence, and intelligent manufacturing systems. This conference is more than forum to present research. It is a global platform for collaboration where the academy, industry unite to shape in the future of the intelligent system sustainable industry transformation. The conference themes including AI-driven automation and smart sensor integration to precision engineers and advanced materials reflect not only to the latest scientific progress, but also the pressing challenges and opportunity facing by our industry and societies. We have received more than 120 papers and selected around 20 papers from presents from various countries, including Thailand, India, Germany, Japan, Indonesia, Malaysia, and Iraq. More than 100 authors involved in contributing their work to LAM 26 from various countries. Also, I would like to appreciate to the funding support Thailand Science Research and Innovation, and also the National Science Research Innovation, and for this conference. I hope you all will enjoy the talk by all keynote speakers, distinguished speakers, and invited speakers to various special sections. And the participants will definitely gain insight regarding AI-driven automation and advanced material in engineering field from distinguished speakers. Once again, I would like to welcome you all to the LAM conference. Thank you very much, everyone.
Thank you very much, the professor, and please remain on the front of the conference room for the group photo, please. Also, I request our beloved chairman of KMUTNB Council Committee, Professor Dr. Theravut Bunyasopon, and the executive board to join us for the front, by the front of the conference room for the group photo together, please. And for this agenda, I would like to ask all the participants in the room to please stand up for the group photo together, please. We will do the group photo like similar to COVID time. The executive team will turn to face the front, and the photographer will take the pictures of the whole room from the front. I may ask all the participants in this conference room, please stand up. Several seconds, please. Thank you very much, sirs and ladies and gentlemen. The chairman of the conference and the chairman of KMUTNB, the Thailand mottos. Yo, yo, yo. Yo, 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 yo. Thai mottos to start strong for the beginning of the conference. Thank you very much, sirs. And for this part, the chairman of the conference and the chairman of KMUTNB Council Committee and the KMUTNB executive team will be absent for the conference a while because of the wreath-laying ceremony for the founders of the KMUTNB for this anniversary day. And they will return later to the conference. And I'd like to inform the participants that our program for the morning session, we will not provide the break time, but we will provide the snack box that will be served in this very room for everybody. And for the first agenda, I would like to invite Dr. Gaurav Ora, research scientist of KMUTNB, to introduce our first keynote speaker, please.
Thank you, ma'am. Sawasdee Krap, Guten Morgen, Ohio, Selamat Pagi, Suprabhat, good morning to one and all present here. The first keynote speaker for this conference is Assistant Professor Nopedol Puduchon from IRAP team KMUTNB. Professor holds a master's degree in automation engineering and a bachelor's degree in mechanical engineering with first class honors from KMUTNB. Currently, he serves as an instructor in the Department of Production and Robotics Engineering within the Faculty of Engineering at KMUTNB. His research are simultaneous localization mapping, 3D perception using visual and laser sensors, and the navigation of both mobile and legged robots. He has authored numerous publications in international journals, conferences, contributing significant to the field such as medical telerobots, industrial inspection, and automated manufacturing. In addition to his research, he is highly successful mentor and team advisor leading his teams to top honors in prestigious global competitions. Under his guidance, robotics teams had secured first position at the World Robot Rescue Championship in Netherlands 2024, France 2023, and Canada 2018. Currently, he has been recognized as an outstanding researcher at KMUTNB. Now, I would like to invite Assistant Professor Nopedol Puduchon to deliver his keynote speech on From Inspection to Intervention, Advancing 3D Multimodal Mapping for Industry and Disaster Response. Over to you, Professor. Thank you.
have some wireless speaker, please? Thank you so much. All right. Good morning. Hello. Sawadee krap. And good morning for everyone. My name is Nopadon Pachun. I am assistant professor from Department of Production and Robotics Engineers. Okay. And today I would like to share our works, that is 3D multimodal mapping for industry and disaster response, and how can it transform the normal inspection into interventions. But before we begin our lessons or presentation, please let me provide guide with some background first. Why we must use the 3D mappings? The reason why? Because our background, when we have to deal with a real-world problem, inspection environment are dangerous, complex, and uncertain, right? Because inside the industrial plant, as you can see here, this image coming from our partner, PDTGC company, is already included a lot of confined space, high voltage infrastructure, or even some high temperature area. On the opposite side, sometimes we have to deal with some disasters. As you can see on the right side here, this figure is coming from our last year. This is the real scenario that we have to deal with disaster. In fact, this one is just like our first time that I have to deal with a real earthquake in Thailand for the whole decade, which for this one is a buildings or constructed from State Audit Office. As you can see here, it's so dangerous and it's already contained with a lot of risk. So we can conclude it's too late for a human officer to work with this kind of situation. That is why we ask some questions with ourselves, our team. Can we send a robot first? Can we? Can do it? Can we do it? Because if you let the robot go first, you can let them to understand, provide some assessment to prepare your information before allow any human to enter, right? That's it. Is the reason why 3D mappings come as an essential. But why 3D mappings matter? Because nowadays for 2D image, it's just with the traditional inspection, it's just it's a manual, right? You have to employ some human to take a picture and have some assessment, which we can conclude that is very time consuming and it's very subjective. You can't use them on a multi-purpose anymore. You have to intentional to do something with them. But with the 3D mappings, it allows us to measure and capture very accurate geometry. As you can see here, this is an example from our works. We can capture the entire plan from biological plan. And after that, when you have accurate 3D mappings result, you can apply them with some quantitative analysis algorithm to measure them, have some risk assessment, deploy some risk assessment software inside, or even use them for our robot. As you can see as the video on the right side here, this is our last 2-year competition. Then when we decide to use our 3D mapping as the input of our autonomous system. For this robot, it can navigate planning by themselves to avoid any occlusion or obstacle in front of them to pass through this environment. That's the reason why we're supposed to use the 3D mappings. And we can conclude that there is no autonomy without spatial understanding. If we don't have any 3D mappings or 3D understanding, we can't do any autonomous tasks anymore. And the core technology of 3D mappings is SLAM. It's just not a funny word or just a funny keyword. SLAM stands for simultaneous localization and mappings, which you can use this an algorithm to let your robot build a map to capture your environment or even estimate its own position in real time, because sometimes you have to deploy your robot inside a GPS denied environment too, right? Like when you just have to deploy your robot inside the building, which GPS signals can't pass anymore. That is why we want SLAM algorithm. And when we talk about SLAM, it's required these three core components. The first one is sensor. You have to choose which sensor that you want to use, which for nowadays we have, in fact, we have 2 or 3 types. First one is camera-based SLAM. Another one is LiDAR. And last one is just like the complement sensor that you can use them together with your camera and LiDAR sensor. After that, when you have a proper configuration on your sensor, next thing that you have to prepare is state estimation algorithm, like command filter, scan matching, ICP, iterative close set point, truncate side distance function to estimate your own ego motions. After that, when you can recognize or estimate your chain of ego motions and capture the 3D environment around yourself, you must represent them with some proper map representation technique, like this video on the right side here. This is my research result when I was a master degree student in this university. As you can see here, this is our system. I just use the normal camera to capture this entire environment and try to estimate the location of my camera, and after that you can use this information to do anything you want, like navigate your drones, control your robot to move around this environment. That's it. This is what SLAM. This is your this is the mass background that I have to talk with them. But when we talk SLAM, as I already mentioned before, we have 2 types of them for nowadays. The first one is visual SLAM here. This is one another works of mine from the past. This is a SLAM. For this one, is have the main advantage that is very low cost, because for now you can buy a camera with just a small buck of money, right? And it can provide you very rich texture result. As you can see here, this is the result when I try to capture this entire environment in 3D space and texturize them or colorize them. But for this one, is have the main drawback is very sensitive to lighting. And sometimes if you decide to go with monocular as your input, monocular camera, you might have to deal with scale ambiguity through. It's just working like you just capture your own eye once and try to guess what is the size of your object, right? That's it. This is what we call scale ambiguity. On the other side, we also have one another type of SLAM that is LiDAR, LiDAR SLAM, light detection and ranging SLAM. For this one, it can provide you with very high accuracy result because it's heavily rely on direct geometry, measurement, and this one is very robust to lighting. Why? Because it already have its own like SOT, active like SOT as a projector, and it can provide you a result in true scale too. But this one also have some drawback too. It's just like a God algorithm or sensor. It also have some drawback that is very sensitive to geometry-less structure, like cornerless or just flat plane scenario when you have to deal with a long corridor. That's it. From this background here, we can conclude that for both of them have the limitation. That is, you can't rely on just only one single sensor system because it might fail in complex environment, because you can't guess whether which kind of environment that you have to deal with. Low texture, low lightings, or low corridor, right? Real situation. That is why we have decided to go with this solution, multimodal perceptions. This is our for now, multimodal perception. So, what is multimodal perception or multimodal mappings? We decide to combine multiple sensing modalities together, like fused airway sensors together, LiDAR, camera, even some thermal camera with IMU-based state estimation. This is the main diagram that leads us for now. First, talk about MU. For this one, main role as motion dynamic estimation, because you can use them with IMU pre-integration algorithm. Like you just try to integrate your acceleration regarding to your time. It will result as velocity, right? It's just like normal physics. After that, what I just try to integrate my velocity again regard to your time. You will be able to guess your current positions, but it's also included with some C when you integrate your the entire equation, right? That is what we call accumulative error. So you must correct them later with some the external sensor like LiDAR or RGB camera. Through this specific algorithm, extended command filter, sensor fusions, fuse everything together. And especially when we talk about camera, because nowadays we already have very powerful artificial intelligence algorithm, which you can use them to recognize or understand what is the current semantic of your objects. Like in this scene here, for example, this one is just like a pole or color of your building, which for this one is supposed to be recognized as static objects and is supposed to be registered into your map. But how about this one? Share, right? Share, you're supposed to know them as dynamic objects, and you're supposed to ignore them or not register them into your maps because you can't use them as the anchor point or reference point anymore. That is what we call semantic understanding. This is the main core or main concept for our current research field and applications, multimodal mappings concepts. But the main key challenge when we talk about multimodal perceptions or multimodal mappings, that is sensor alignment. Why? Why is matter? Because our sensors must share the same coordinate frame when you just try to recognize made its own positions that change over time. Even with some small misalignment, it might yield a result as large mapping error because you just have some wrong measurement, and when you just try to guess which one is correct, it's very, very hard, right? So at first you're supposed to calculate together first, which with a traditional approach, we heavily rely on target-based collaborations, manual collaborations, which for both of them is very time-consuming. You have to prepare your target, but with our approach now, we decide to go with this approach, that is target-less LiDAR camera extrinsic collaborations. This is our result here. This is colorized point clouds information from our system. Is the main concept for this one, or the main idea, I decide to extract some S information from both image and LiDAR. After that, try to project two of them together and estimate this term here, the error that we call reprojection error, the misplacement between your image plane and 3D objects, between your LiDAR and camera sensor. After that, employ with some optimization algorithm to minimize your error. Try to guess what is the relative position between your LiDAR frame and camera frame and its own orientation in a quaternion form, something like that. After that, you will got this result, that is the relative position between your LiDAR and camera. And when your multiple sensor is just unified together, you can use them to create very good result. As you can see here, this is the result of our system. This is a fusion benefit. That is, you can use them to create very high accuracy 3D mapping result, as you can see here. And it also include your robustness into your system too, because you just have system redundancy on both textureless and geometry-less environment. And this is an example from our output. On this left side here, this is a colored point cloud result from petrochemical plant. As you can see, we just captured this entire building here in a very good result. But you can use this one directly because you don't know the way how could you interpret your problem inside this one. So would it be better if we can fuse or augment one another's spectrum inside? That is the thermal augmented map here. This is one of another result from this system. Through this one, now you can recognize where the current problems or the current issue inside your system. Its location is here, right? The red one. You can use this one to locate some corrupt insulators that you must replace them on the next preventive maintenance loop, something like that. There is a benefit from sensor fusions for robust perception. And this is, in this slide, I would like to show or share our result in real time. This is the result when I try to capture some of our building in Faculty of Engineer. This is 89 building, which through our software can perform everything in real time, try to recognize or estimate its own location and capture the entire buildings, as you can see here, which even we just run them on real time, it still yield very good result and very accurate result, as you can see there, because we just increase its robustness through both of camera and LiDAR sensor. Okay. Now, on the next section, I would like to share our use case, a real use case in the industrial. For the first one, that is heat loss analysis. This is one another work that we have to join with PTTGC company to estimate their heat loss locations. This system is 3D thermal mapping for energy efficiency system. This is the entire pipeline in this software. First, I just deploy multimodal mappings algorithm to recognize or estimate my own eco motions. After that, project the thermal image into my 3 models, as you can see here. Through this step, now you can recognize what is the false location or corrupted insulator inside your system, like this one. In this pipe here, because in fact this one inside is also installed with some insulator, which for now is just corrupt or falling down inside, which you can't see them from the external. But through 3D mappings and thermal camera, you can recognize where is corrupted location or falling down location of the insulator. And step number 3, this is like the optional. You can use this model to estimate your heat loss. Try to quantify them, like just capture in this area and meshing them, and then use the normal equations such as the law of convections to estimate your heat loss. How much you spend in this location for sure. And this is the benefit for this one. You can use them to identify insulation defect and reduce your energy consumptions and support some predictive maintenance team to recognize or locate the location that you're supposed to looking for or try to fix your insulator's problem. Okay. This is another use case from our team, that is infrastructure and volume estimation. As I already mentioned before, you can use our software to inspect the insulators, to detect a crack, heat spot, and prevent some power failure in electrical application too. As you can see here, we can use this 3D map to locate where is the defected location of this device inside a petrochemical plant here. Another application, that is volume estimation. We also have this kind of application too. You can use a 3D model to estimate your stockpile volume or stockpile measurement, to use them as the input to plan whether when you're supposed to buy a new lot of fuel or coal or any organic substance. That is, this is one another use case from our system. And even on the disaster scenario, we also have some use case too. As already mentioned before, this is the result from disaster response scenario when we have to deal with collapse building scenario in Thailand from our last year, which for this one is very challenging because we have to deal with unstable structure, limited visibilities, unsafe for human rescuer. But at this time, we decide to let our robot go through in this building, these collapse buildings, to capture and measure the 3D mappings for interior space, and try to let them detect some victim or create or make some part assessment to check with her which part is safe for the rescuer, and use its result to support the rescue planning team here. This is the real one. This is the real application for our 3D mappings application. That is, you can use this entire information to plan which way that you're supposed to go inside first to check or detect some victims. And we also provide our information to another rescue team too, as you can see here. this just happened from our last year. And if you would like to inspect or check or play with real result from our 3D mappings algorithm, you can use this attached link or just scan this QR code here, and then you can play or rotate them over your mobile device too. And this is the result. As you can see here, we just capture the entire area, and you can use for planning tasks to plan whether which way that you're supposed to go and searching for your victims. This is our result. In fact, this one is a combination between a drone mapping algorithm and ours. All right. Now, let's go back into our main keyword, that is from inspection to interventions. What is the result, real result from our 3D mappings or multimodal 3D mappings? That is a paradigm shift for now, because the traditional workflow, when your inspector, they have to go to work in a real industrial plant, they have to inspect, create some report, and let human make some decision to take some action, as you can see here. But with our works, with 3D multimodal mappings, you can let a robot to inspect, try to understand what is happening inside your plant, and use them as your decision supports when you try to make some decisions, or even create some autonomous or assisted interventions too when you have a plan. For example, when we have to do with some heat leak, you might use our result to prepare the automatic repair plannings. Faulty insulator, okay, now you can use them to plan how many plates that you have to replace the insulator inside. Or even with some collapsed structure, you can use our robot to guide your rescuer whether which part is safest. Yeah, that's it. This is an example from our main concept of today. And this is our future directions. That is, we will go toward to autonomous spatial intelligence. That is, for now, we have a plan to create some real-time digital twin, as you can see here, to let our robot to go inside, inspect the entire plan, capture thermal information with some gate digitizations, like this one, to keep measure everything in real time, keep updating them, or even use some AI-driven damage assessment inside. And in fact, from the past, we also have some autonomous inspection robot too. This is our another works. This robot, we have to collaborate with PTTGC, petrochemical plant or company to use them to inspect this pipeline here. And we also have a plan to deploy our 3D mapping algorithm inside too, to capture everything in real time and locate which location have lowest thickness left to create some preventive maintenance plan. Or even this drone. Now we have a plan to fully automatic drone, which we can use our 3D mapping sensor as fake estimation algorithm. From this, we will result as very accurate and stable drone. In fact, we can deploy inside indoor using. And before we finish up this presentation, please let me provide you guys with some demonstration from our real robot. All right. So please wait for a minute. I will let them show a result from our 3D mapping algorithms. So please give us a minute. Yeah, this is the entire information from this room. You can capture this entire room in real time or use them to recognize what is your current locations in real time. We can control this robot wirelessly or let them move autonomously too. Can you show us some zooming result too? Okay. Oh, you are holding. And for this entire structure, it has been built by just only undergraduate students from our teams, IRAP Robot Clubs in Thailand. And this is the graphic user interface that has been used by a user or the operator to control this robot to move around some occluded area or disaster response scenario. Yeah, this one. But in fact, we also have another field that in fact we can explain them more later, because we also proficient in dexterity tasks to control this robot arm to move around autonomously. This is why we also got a prize as best in class dexterities or manipulations, mobilities, autonomous mapping, and won the champions for 10 times for now. And yeah, this is all of us today. I would like to thank you guys, the audience. This is my first time on behalf as keynote speaker, and for now I just kind of be very nervous. For any mistaking, please forgive me, and I hope I will find some usefulness from my presentations. And if you would like to go further, I'm welcome. And if you have anything that you would like to discuss, please feel free to discuss with me. Thank you. Yep. Yes, on the ship in real time, because for this robot we also installed 2 powerful computer inside. Yes, so everything is done in real time. In fact, not that much, because we just rely on extended command filter, which you can reduce a lot of computational power that you requires. Yes. Yes. If you ask me this question, in my opinion, I would still prefer with LiDAR, because you can measure everything in real time and in 3D space, right? And you can even make some false measurements when you just force them to deal with some parallax information, which this is my decision why I guess that LiDAR is better. But when I look at them, when I just assume myself as Tesla, I guess they just trust that
camera can do it.
Camera can do still, but I don't know whether it can deal with some darkness or low lighting.
No, yeah.
No, yeah.
But does your LiDAR help
Yes.
in having your algorithm understanding more from cameras?
Yes.
Okay, that's important. Thank you very much. Very inspiring talk. Thank you.
Thank you so much.
I have also one question, and
Yeah.
for the first time you do it very. Your speech was very good.
Thank you so much. Still nervous for now.
It is possible because we have a European project to identify cracks on the airplane in composite structures.
Yeah.
Do you think it's possible to modify your system, your configuration to use it for airplane structures?
If I would like to answer it now, I think it's possible because in fact you don't have to deploy our hardware or system on this robot. In fact, it's just a handheld system. Just group multiple sensors together like LiDAR, thermal camera, and RGB camera. And then you can let any operators to measure or capture your entire 3D space. So based on your question, I guess it's possible to capture or deploy them as crack detection system for airplane. Okay, that's discussed. Okay. Yeah.
I'm Troy from Korea Digist. It is very impressive,
so much.
especially 10 times championship in the world with undergraduate students hands-on experience. Well, you compare the accuracy with the mono sensors and with the LiDARs and the other multi-sensors,
Yes.
that one. But I think for the rescue, I think time concern is very important points too. So did you compare the time to get in some the points, certain points, instead of the accuracy?
Oh, you mean that we supposed to focus on time, not location, right? In fact, it's my opinions. Yeah, time is also important too, but in fact, we do. We also detect some stiffness or misalignment too. Yeah. Okay, thank you.
Okay.
But in fact, we can discuss together later about this topic.
I'm having one question. Yeah. Very impressive keynote speech. Congratulations to you.
Thank you so much.
So, we know, this is a ground rescue robot,
Yes.
and we have aerial rescue robots and underwater rescue robots. So, when we compare ground rescue robot, what is the impact with aerial rescue robots? Because it's more impact, right? When we compare with the aerial rescue robot, very quick, we can get all information.
Yes.
But for the ground rescue robot, it will take more time, right? So, what's your opinion? What's your thoughts about that?
When you try to compare between ground robot and aerial robot, in my opinions, ground robot is still safer for victims, right?
Okay.
Because you don't have to deal with any rotated or spinning propeller, and you have to beware some misplanning on navigation on your aerial. Because if you have any misunderstanding or wrong navigation on aerial robot, it might yield result as very.
Okay.
Yeah.
Okay, thank you.
Thank you so much for yours.
Just another question. Thank you for the very good presentation.
Thank you so much.
Do you have any experience under how it works under very rough ambient conditions? I mean, when you talk about rescue situations, you talk about fire, you talk about dust, you talk about any other rough conditions.
Yes.
What are their experiences, or what do you project?
When we have to deal with some, in fact, we don't have any experience with fire yet, but with dirt, debris, dust, in fact, we decide to go with another type of robot, not this one, by reduce this cost and use another manufacturing technique like 3D pins, because for that kind of robot, you you're allowed to lose them or let them break in real time, or you can even produce them again later to deploy them again. Yeah, this is our solution for now. But we also have some plan to redesign or reproduce this one to more stable, because this one just like Formula F1 car. We just try to go as fast as possible, right? But when we talk about robustness or reliability, it might a little bit lower than the normal one. But in fact, we also have some experience to create some bomb disposals, robot too. And at this time, we have redesigned everything again to protect some dust, debris, and water. But we don't have any chance to deal with fire. Thank you.
And which energy system do you use for energy storage for propulsion?
For now, our propulsion is rely on just a normal battery. Yeah, but in fact, one of our colleagues he's a master student who participate and join in that program because he have some scholarship to participate in research on fuel cell too. Yeah, so for now, we still have some plan to rearrange our power source from battery into fuel cells if it's efficient enough.
So we have an approach for cooperation.
Thank you so much.
Thank you, Professor, for the wonderful talk and your fruitful discussion. Your perspectives on innovative approaches. Your perspective on innovative approaches to 3D multimodal mapping and their application in industry and disaster response are truly thought-provoking and inspiring. Thank you once again.
So thank you very much for both Dr. Gaurav for introducing the first keynote speaker. Olive, right? The name? Yes. Olive. This is Olive. Please give a big hand for Olive Robot, please. So thank you for the first. It's good. The first. So the first speaker, the team, Dr. Gaurav, and also Assistant Professor Noppadol Patchun for the next second keynote speaker, Dr. Mohit Kuma will be the one to introduce our second keynote speaker. Dr. Mohit Kuma is research scientist of KMUTNB, and he will introduce our next keynote speaker. Please, Dr. Mohit.
Thank you, Ms. Honey. Good morning, everyone. Swadee Krab. I will now introduce the second keynote speaker, Professor Dr. Ahmed Atif from University Technology Malaysia. Professor Dr. Ahmed Atif is a researcher and engineer in expertise in the field of robotics, mechatronics, and system integration. He received his bachelor's degree in computer engineering and his master's degree in mechatronics and automatic control from University Technology Malaysia, and his doctorate in system integration from Okayama University. In addition to his academic credentials, he has also gained valuable industry experience through his visiting research fellowships at the Tokyo Institute of Technology and his fellowship with Ericsson Malaysia. He is the professional engineer with the practicing certificates, a chartered engineer, and a member of several professional organizations, including the Malaysia IEEE Robotics and Automation Society. During March 2019 to 2024, he served as a director of Center of Artificial Intelligence and Robotics at University Technology Malaysia. He has received numerous accolades for his research, including the Top Research Scientist Malaysia Award in the area of robotics in 2020 and Fellow of Malaysia Academy of Science in 2025. His research interest includes actuators, field robotics, and bio-inspired robotics. He is a member of 2 ASM special interest groups, namely ASM SIG Biodiversity and ASM SIG Robotics. So I heartily welcome Professor Dr. Ahmed Atif to deliver his keynote speak about AI-driven fields robotics from lab to market. Over to you, Professor.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And a very good morning. Sawadee krap. And a welcoming session that we have just now from our first speaker. And I will be continuing the second talk. Something related to what our speaker have been talking on AI-driven field robotics and some experience working from lab to market. Okay, so this is some of the sharing that I would like to talk about today. I'm from University Technology Malaysia, so we have few colleagues also from UTM, and under UTM we have a center called Cairo UTM, and I'm also a director and a CEO of a spin-off company called as A2 Tech. So before we continue, I would like to wish for all who are fasting today is our first day of fasting, happy Ramadan, and for those who have celebrated Chinese New Year, Gong Xi Fa Chai. Huh? Oh, they will do it there. Okay. Okay, next. So this is a little bit of my background that have been introduced. I'm an academia from university. But then some of the experience that I have, I started my spin-off company back in 2022. So that's why I would like to share some of the challenges that I have from becoming a lecturer to becoming a CEO, still in the learning process. Okay, next. Cairo is a name of a city, okay, in Egypt. But then Cairo UTM is in Malaysia. Okay, when you search in Google, you have to search Google for Cairo UTM. Okay, if you go Cairo only, you go to Egypt. Okay, so we have 2 offices, one in Kuala Lumpur, and the other one is in JB, which is near to Singapore. Okay, next. I'm the previous director. Now we have the current director, Dr. Ibrahim, from Kuala Lumpur. Okay, next. Okay, so the topic that we would like to talk about is on how robots that we normally see and how we want to bring it from lab to the area. So I think the first speaker had some of his work coming from the research that we have been doing, applying it in some of the disastrous area. So we see that some of the robots is nicely put, okay, nicely installed, commissioned, but when we want to bring it inside, so there are a lot of challenges that we have to take into consideration. Okay, next. So on fields, we can talk about different areas. So the speaker was talking about area of oil and gas. Maybe there are some pipelines of energy or maybe steams. And we also talk about disaster response just now for search and rescue. I am also working in some of the areas of disasters. But then we also have agriculture. Malaysia is known for palm oil. I think for Indonesia in the region, maybe from Thailand also, there are some palm oils. Okay, so how the improvement of mechanization can be applied for palm oil methods, especially on harvesting palm oil fruits. This is a very challenges issues that people have been trying to solve at the moment. And for the other infrastructure, as well as in maritime, as what Dr. mentioned just now. So there are many ways on how robots are being used, especially on the ground, underwater, and also in area. So the key differentiator is on how the means of control. Should we use cable-based? Should we use wireless communication? Should we use battery? Should we use connected AC? So is it AC or DC? These are all that we have to configure when we are talking about field robots. Okay, next. So in this uncontrolled field, because we don't know the area, right? So sometimes we have poor visibility. I have experience putting my robot underwater to do inspection of bridges. So the turbidity of water, if we are in a good island, like Hawaii, I don't know, Hawaii, is it good water? In Malaysia, we have Sabah area. Okay, Sabah is very near to Manila. So we have a very good water vision. So you can see roughly like 1 meter, 2 meter. But then when you put the robot underwater to do inspection, the vision instability will be roughly around 5 to 10 centimeter only. So very bad. So secondly is on sensor contamination. So if we have dust, debris, so that's why sometimes when we use sensor, we have to look on the quality sensors, whether the calibration are being done properly and how the data will be exactly as what we intended to know. GNSS is something that I think for those who are working with GPS, we have some issues, especially we are inside buildings. Okay, so you have another issues on how to relocate your robots within the area. And finally, on the unstable communication. So between these four things, one of the main challenges is on communication, on how you want to get data. Secondly, on how you want to manage the battery consumption, because when you send robots, if it is wirelessly, so then you have some limitation, because battery will not last long, depending on what type of battery that you use. Okay, so this fundamentally changes everything on how you want to control when we are talking about field operation. Okay, next. Okay, so then we talk about intelligent versus system engineering. I think Prof. Choi also was asking on how we want to look on accuracy versus robustness, reliability. So this is a very big issue that we have to talk about, especially with industries. People in industry want to know whether your solution could solve your problem or not by providing high data, whatever. But then if this data is helpful, then it's okay. But if it is not helpful, then we have to go back, listen to the company or the problem, problem statement from the industry so that we could solve as easy as possible. So we have system complexity when we are designing, the power management, all these issues, and how we want to look on this AI component that may help, but then we'll have roughly around 20% contribution within the all problems that we can solve. So I also work on some robots. Okay, these are some of the robots that we use in palm oil. So to move, do some loose fruit collection and so on. So when we listen to the industry, so they will advise us what are the current SOPs, what are the current standards that they have used so that we can follow. We as academia, I'm an academia, normally we don't listen. We tend to think that we know everything. We do papers and everything, right? But the most key important point is to listen and know what's the main issue. Then we try to navigate and try to solve based on that issue. So this is one of the lessons learned as academia that I am trying to improve from time to time. Okay, next. Okay, so based on this, the outside control environment is very challenging. So we talked about just now the timing challenges. Okay, the timing challenges on how, for example, if you want to do search and rescue, yes, depend on what function that you want to go for. If we want to go and rescue, so the first thing is whether our solution will be enough to bring the survivor, or is it going to be on identifying a main issue. So I think what our keynote speaker was talking about now is mainly to identify the area. Okay, if there are some incident happen, normally the responder will come. So if we have this kind of solutions, maybe to make sure that the responder will be safer, so sending robots will be better. Okay, but if there are some survivors, so the first thing is on how to make sure that we can bring survivor out. Okay, so that's some of the operation as standard operating procedures that we have to know. Okay, and these are some of the robust issues that we have to keep on improving so that the solution will be more mature and later on it can be applied. Okay, next. So these are the two comparisons that we look for. Normally in academic metrics, we want to do the detection accuracy rates. Okay, the recall precision score. These are all if we are going to use object recognition and so on. MAP, I think for those who are working with AI, object recognition, you know this. But then for industry metrics, mean time failures, okay, how frequent the failures will be resolved, okay, the operational uptime percentage, the service and maintenance intervals. If we have a robot, service that you can provide so that the solution can be continuously ongoing. Okay, if you have some issues, how quick you can replace your system that you can, the company or the user can use continuously. The lifetime cost of the ownership. So the 98 detection rate impressed researchers, okay, but a robot that ceases operating after 3 hours delivers have no commercial value, okay. So this is the hard issue that we have to keep on improving, and I think I'm very honored to be beside Dr. Sri Pongs, okay, so he have experience in industry. More than 100,000 Toyota cars are produced under his management. Later on, maybe we can learn also. So industry does not purchase accuracy, they invest in reliability. So please correct me if I'm wrong, sir. Okay, next. So the field methodology breakdown. So when we want to go for this kind of field, so we as researchers, we have to look on the network monitoring, the real-time latency tracking. If we have a lot of sensors on our robot, so we have a lot of data packet that we have to send out. So what kind of communication that we have to use? How reliable is the data? So we don't want to have latency in our videos, streamings, and so on, right? So that's one of the main issues on communication. Secondly, on the power management, there are some solutions that we have to use tethered or maybe cables. So we have less issues on power because the continuous power is coming from the AC line. The AC will be converted to DC, so then you have longer power management. But if we use battery, so then you have your power integration. So sometimes it can be, depending on how big is your battery capacity. So for example, in palm oil industries, they want to have an operation day to evening, as at least 8 hours operation. So you have to make sure that your battery, if you are developing some solutions on palms or maybe in agriculture, you should have at least 8 hours. So having more, 1.5 will be further better. Okay, positioning system. So the fusion of sensors is very important, as one kind of sensor will not be sufficient, okay, because I think the first speaker was mentioning on how he combined the SLAM methods from the camera and also from LiDAR. This is a very interesting work. And finally, on the repeated trials. Okay, trials is very important. We have to keep on testing, pushing until the limit, looking at what are the limitations of our system, and then keep on improving from time to time. Okay, next. Okay, so what failed first? I think this is one of the things that I have mentioned. The latency is one of the issues, the sensor obstruction, the calibration drift, and then the terrain behavior. So when we develop some of our robots, we don't understand exactly what is happening on ground. So then we have to come back and then reconsider. Later on, we redeploy it again. Okay, next. So one of the things that we have to also ensure is safety, okay? Because safety is one of the main issue when we are talking on different industries. So in industries that don't have, for example, if we are using it in agriculture, some of the trees may cost thousands maybe, or maybe hundreds, okay? But if we are talking about using robots for civilians, okay? We are developing robots for civilian cars at some of the yards, okay? Because for example, from Thailand, manufacturing some cars, export to Malaysia, so then we have to keep the cars, okay? So maybe from Germany, from Thailand, from Japan. So all these cars will be kept for a certain time before it will be used or maybe, distributed locally. So currently, we have people guarding the area. So on how we want to improve that, so we are replacing it with a robot. I will show you later. So one of the issue here is how your robot is safety enough for not hitting the other cars, okay? So if you are hitting a BMW, so you are going to cost a lot, okay, for your customer, okay? So we don't want to have this. So we need to have a fail-safe strategy. So how to reduce the blind spot mitigation and also to use the multimodal sensors that the speaker was talking about just now. So in-field robot safety defines market access. Intelligent system without a structured safety design cannot scale to real deployment. I think this happens, for example, now before we have a robotic arm. So robotic arm now are becoming more intelligent. You have a cobot robot arm, right? So these are improving in terms of how human can work together with machine and robots. Okay, next. And this is some of the terrain and energy constraint. I think I have been talking about this as well, the nonlinear behavior, the motor load, the battery discharge, and sometimes talking about the usage of our system, we want to hand over to our customer. For example, for battery, if you have your phone, what is the normal rate charging will be optimum for our phone? Anyone can guess? Between 0 to 100, what is the optimum charging range? Do you know? Anyone can guess? 20 to 80. Yeah, that's correct. Yeah. So make you, when you want to keep your battery lifelong, so please charge when it is around 20% up to 80%. So if you use some of the phones, you can do some settings, not to go up to 100, because you're going to increase the issue, the lifetime of the battery will be. These are some of the knowledge we have. So our solutions, instead of we have to also hand over the information to the customer. Okay, so we have to also know what are the issues that we are talking about when we are dealing with the issues in the field. So as I mentioned just now, so some of the work that is in agriculture will be different flat terrain, because some in agriculture you have and so on. Okay, next. So the valley between prototype and products, and this is some of the experience that we have from the lab to market that I would like to share. Any one of you know the TRL? I think the gentleman in front of me is nodding head. How about the students? Do you know what is TRL? What is TRL? Anyone can guess? Technology, readiness, level. Okay, so it was proposed by NASA, if I'm not mistaken. And then people have been improving. Different countries have different skills of TRL. But when we talk about TRL, most of the academic will putting the product range and between TRL fundamental 1 until 3, or maybe at most 4 or 5. To go until 9 is quite very challenging. Okay, how to scale up, okay, between the product that you have developed, having your IP, to go to the market. Maybe sometimes you have to collaborate with other partners, industry partners, so that you can scale it up. So different strategies will be depending on how your product will grow. So normally we start first with research, from theoretical foundations and innovation. Then you see some of these algorithms, control demonstration, peer review publication. This is what we do as academia. Secondly, we go for prototyping, have the POC, or from POC we go for MVP, okay, a minimum viable product, so that the work that we have from a POC can work at the real environment. Okay, so the working system, how we want to look at it, the limited deployment and the POC validation. We have UAT. Okay, I think you know what's UAT? User acceptance test. If we have a user, so when we want to make sure that the product that is developed being accepted by the user, so we have this kind of test so that the user will be approving, especially on the project that we are working on. And finally, on the products, we would need to have certification. Okay, this is some of the things that I have learned. Some of the products don't go until the high and very complex certification, but you want to go for exporting or maybe to make sure that you are following a certain standards, we have to look at the standards that we have internationally or maybe locally in your government. So the sustained maintenance, life cycle management, and also the commercial viability. So these are some of the loops that we have to look for to know how we want to go from the fundamental stage up to the market stage. And this will depend on different kind of products. Some products will be faster, some products will take longer time, especially, for example, in medical. So you need to have more time doing testing and so on. Okay, next. Okay, this is some of my work. Okay, I graduated from Japan, PhD in 2010, and then I start spinning off my company, 2022. And people say, you are crazy, huh? You have to do many things. So a Senate member, on my head. Senate member have to, a Senate member, so we have to have meetings a lot. Before the student graduates, we have to do a lot of approvals and so on. So my area is in actuators. I'll work with bio-inspired robotics, in soft robotics. And some of the work that I do with undergraduates, masters, is on automation and also developing robots. So next to me is my previous student, a PhD student, but now he's a COO, Chief Operating Officer of the company. Okay, next. Next, please. So what we work on, if you look on the left side just now, soft robotics is something that's more highly in fundamental at the moment. So I can publish a lot of papers there. But then when we want to go for automation, so we are now working with robots that requires, assisting operation that requires limited human abilities. So we started off by developing a smaller robots. Before it was a final year project, but then we improved from time to time to make sure that the reliability, the robustness, and also how it can solve the actual problems. This is one of the robots that we are developing. Okay, next. So we work on this tele-operation field robots. So on the left side, we focus more on the inspection. The middle one is on surveillance, and the right one is on the farm mechanization, on agriculture. Okay, next. So Inspect2D is our first baby. Okay, if you ask me, so this is our first product that we bring from the laboratory to the market. So now this is an inspection robot, okay, that we can see in many solutions provide as similar other solution provider, but then we have our USP, unique selling point, on how it can be used. So currently it is serving roughly around 66 hospitals in Malaysia. So what we do is we inspect the EHU, aircon air unit. So for aircon, you need to do maintenance. So normally for hospitals, they have to go for maintenance every year one time. This is where we identify and we try to solve. Okay, next. If the are not being maintained, we have the issue of sick buildings syndrome. The issue when you come to office, you feel sleepy or you have dizziness. So this may be due to the air that we are breathing in. Okay, next. So what we propose is a robot that can be, next please. So a propose is a head-based changing module. So a sensor that can do a robot that can do mapping, we can do inspection, we can have a sensor module, we can also do cleaning, and finally we have a reporting tool using AI. So this is one of the unique selling point. So when we have this kind of functions, so it will ease the process of doing the reports after. So you don't have to do offline, everything can be done online. Okay, next. So these are some of the functions of the robot when we try to inspect. It started off with ducting. Then secondly, some of the customer ask me, okay, can you do inspection of piping? Okay, so then we start doing pipes. Then thirdly, now we have another call to inspect under building. Okay, you know, for building you have piles. So sometimes underground, the condition of the piles are not proper. So we can also insert this robot inside. Okay, next. So this is our USP that I have just highlighted. we want to make sure that how our product will be different with others. Okay, next. Okay, I have some videos for you.
Inspector by A to Tech.
Next one is another robot that we talked about just now on how we want to make sure that the operation or maybe viewing some of the areas. So normally we have CCTVs in some of the areas, but then on how to make sure that the view of CCTV can be more dynamic, so then people have the guards coming around and looking for areas which is prone to safety issues. Okay, and we have probably around 63 million losses due to solely physical security breach. Okay, this is a world statistic data. Okay, next. So this is one of the things that I would like to share. We started off with a small robot just now, but then we move on from one robot to another. Okay, this is the circle loop that we are trying to keep on improving ourselves. So there is one robot on the disaster that we are also something similar. It's a good collaboration potential that we can work with KMUTNB. And the DHAS is a robot that we are working for the young, okay, surveillance. Okay, next. So we come up with this robot. So the left one is the first version that we developed, and the right one is the improved version. So it is an AI-powered petrol robot for intruder detection, real time, and support autonomous navigation with wireless charging for non-stop operation. So it's like your Roomba, you have your vacuum. So when you want to clean it up, then you let the vacuum go. The vacuum want to charge, it will return. So something similar with this concept, just that it is a little bit bigger. Okay, next. So this is the robot specification. We have some of the sensors, the charging hours, the operating hours, the safety issues, have secondary system, collision bumper, emergency stop, and so on. So how we work with this next is, again, these are some of the units that we have inside. Okay, next. And this is the operation. So normally how the robot will go on and then identify the route, routing, and then if there are some intruders, so the AI function will detect and then send it directly to your phone. So if now somebody coming, I can see from my phone, okay, it will be updated directly. Then you have your AI, the report will be generated directly in a daily or maybe weekly. Okay, next. This is the process. I think similar for those who are working in robots. So you have to start with some algorithms development, navigation, the SLAM, and continue. Okay, next. And then we have, of course, day and night coming in some of the teams to ensure that the operation is in a good way. So then we have indicators. These are some of the response that we have received from the industry. Okay, how to make sure that your robot is safety? So we are putting it in few different colors. Okay, for example, if you are in very short range, you have red color. You can have a buzzer. If you are far away, the robot will be blue. So this is to ensure for the customer to know that the robot will not hitting their. Okay, I'm not going to hitting a Hilux or maybe a BMW, a smart car, whatever. So to ensure that we are going to do operation safely. Okay, next. So then we tested a lab area. Then we go to the actual site and we decide. Port Klang is one of the ports that we receive a lot of incoming imported items. So we want to do a 24-hour surveillance and a command center that will be doing continuous monitoring. And also the data analytics. Okay, next. And this is the MVP, the minimum viable product testing with the customer. So on how the right guy looking at this. So he's the CEO. So presenting to CEO is different. Okay, from Viva. Okay, Viva is a different way of how you want to present your academic work. Presenting to CEO how to ensure that he will buy your product. Okay, so this is one of the things that is very, very challenging. Okay, next. So then we have intruder detection, the cars that we have around the area, and how we want to ensure that, okay, if there are some intruders coming, you can have it directly to your mobile alert notification. Okay, next. And we also test for during the night time how the sensor will be working and so on. Okay. Okay. Now we are going towards the end of the presentation. Okay, field deploy is essential. So based on our experience and also still learning, to test outdoor early is very important. Okay, we have lab tests, but then to do it outside to the area that we want to go for is very important. To log everything, to keep all your data. Okay, what are the improvements being made? Sometimes you have algorithm A, and then into algorithm B, and then you forgot what you have been improving in algorithm A, which is very important for your improvement in algorithm C. So this is very important for you to timestamp. So if you are working in ROS, you have to look on your GitHub and so on all this management. So design for maintainability. So on how to make sure that this can easily maintain. So if you are working with modular design, so that will be important for you to ensure how the teams will be managing it properly. And number 4 is simplicity, to make sure that simplicity beats complexity, because customer would like to love more simple things rather than complex items. And reliability wins funding. So meaning that to ensure that we can go and bid for any products, to be sure in the customer interest is to have a reliability direction. So this is what we are also learning. Okay, finally, I think for the final slide that I would like to share, Field Robot is not about building smarter robots. It is about survive in reality. Okay, so if your robot cannot survive in rain, dust, unreliable network, so that will be very difficult to be sustained in market. But this is quote in your area. Okay, there are robots that will be inside buildings. Okay, for example, in manufacturing automation, you have industries that you are working on that may have some different standards. Okay, so this will be rely on your area, but I'm talking more on the field robots that we are improving from time to time. So I would like to thanks to all RAM 2026 for inviting me to share some of my experience and for KMUTNB for host this very nice conference session, and we can learn together and exchange ideas together in this session. With that, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
I have a question for a special application, because we search for a robot for a pipeline for to the gas come outside, but a robot who is outside of a pipeline, so that he can look through the ground to the pipe. It is possible to do this?
Okay, so this is very interesting, okay, because on how to inspect what is inside, but then not coming from the inside view, but coming from outside. There are a lot of sensors available, but then how the integration from the sensors with the robot. Because normally, there are means for some of the operation, for example, is it on gas?
Gas pipe.
Gas pipe, for example, for gas pipe. So the normal SOPs, the normal standard operating procedures when they want to do detection, so they need to have like a certain sensors. So for us as a roboticist, we want to know what are the current available sensors that are being used. So is it good enough, calibrated enough? Is it the data reliable for us to get the data based on what the customer wants? So if that sensor is okay, then we will integrate with the deployment methods. So deployment method depending on the material. So if it is a steel, then maybe we can use magnetic. If it is not a steel, then maybe we have to use a certain mechanism to crop and attach or maybe detach. But the gas in industries, the standard is very important. I mean the safety standard, because we have like level 0, level 1 with carbon, right? So in some of the turnaround time, we can come and do inspection. But if it is not in the turnaround time, that will be very dangerous. So the safety of the robot itself will be very important. So to answer again for your question, it is possible. There are some research currently ongoing. So if there are some good problem statement, the gap is not yet being identified, so then maybe we can try to see how we can come up with that kind of solution. Thank you very much.
Yes, thank you. We speak in
Sure,
detail
sure.
of this. But in Europe, nearly 70% of the gas pipes are made from plastic.
Plastic, yeah, okay.
It's the problem that you cannot use magnetic.
Magnetic,
field,
yes,
no?
yes. So for plastic, maybe there are some methods of
Other
treating.
sensors, yeah.
Yes, yes. Thank you very much, Prof, for your question.
Hello, Professor
Yes.
Atif. Yeah, I'm having one question. Really very amazing talk from you. Thank you very much.
Prof.
So my question is very general. So in research and innovation, like bringing a product from lab to market, it's a very difficult transition in research. So can you add few points regarding how you made your product from lab to commercialization? Because all are your young researchers, so it will be good for everyone how to make like from lab to the commercialization.
Okay, one of the main motivation that I have, there are a few, but then one of the main motivation, I have more than nearly 20 PhDs, and then masters and undergraduates. So then we are producing good talents, okay, from our universities. But some of them want to retain, but I don't know how to retain them, because after one grant finish, then I have to search for another grant. So one is on the sustainability of the group, on how to maintain. So then because in Malaysia we have less grants to apply, to open out for industry grants, or maybe from commercial grants, or maybe from international. So that is one of the ways how we want to sustain our lab. So other than the sustaining the team on the funding, so then we start to think of how we can apply from different grants. I have applied few international grants, but then the commercial grants require me to have a company. So this is one of the pushing factor why I have to come up with the company. So I have some of my students, they have their own company. So then then we have some discussions and we join some of the talks. So we see that, okay, maybe there are some to bring ourselves out from the lab. But this is some of the things that need to be, because there are some procedures. Okay, I have to work on the proper channel on how to make sure that while being in academia, we still do some commercial work. Okay, so that's one of the important procedures that we have to talk about. Ways, because sometimes there are students of us who can be the, or maybe some operators that can manage the project. So that is also another method that we can enhance, but that we as professors can be together. Because doing pitching is one of the things, because normally we talk here maybe 30 minutes, but talking to industries, talking for 3 minutes, yeah? It's like you go like Shark Tank. So that's the way, that's one of the things. So maybe in short, depending on how we want to grow, depending also on the products and how methods of realization, maybe on sharing to the other companies. Yeah, a few. Yeah, maybe later I can share more.
Thank you, Professor.
You also said that you have robots underwater. So what are the main objectives for, or what kind of data do you collect and what you use for?
Okay, for the underwater robot, we started a commercial unit. Okay, because when we work with some of the products, we have our self-developed robots, and then we have a commercial unit that we can compare. So when we move our first robot, we see that, okay, maybe the commercial unit, because some of them are quite cheaper, so we can use it. So what we use now, underwater commercial unit, if you know Blue ROV, or maybe from China you have a chasing robot, so these are quite cheap, if compared to when we want to develop one. Okay, so we use AI to know what are the data that we collect. So I use this robot to do structural inspection, because we have a lot of bridges, so we want to know the rigidity of the structure, so we use the robot and then do the inspection each piles. So there are bandicles. These are some of the issues in bridges. So the bandicles are the culprit. So if it is too severe, then we have to do some maintenance, rehabilitation on that one. So this is some of the work that we do. And we, because I'm not from civil, we collaborate with people from civil. From this data, you analyze what are the problems. So when we have this data collaboration, so we provide the algorithms, so they are the experts, then we can provide some solution to the customer. Okay. Thank you very much.
Thank you, Professor, for your wonderful keynote address and discussion.
Okay.
Your perspective on the development and real-world development in AI-driven field robotics are highly informative and meaningful. Thank you very much, Professor.
Thank you very much, Dr. Mohit, and also Professor Dr. Muhammad Atif, Professor from University Technology, Malaysia. Next, I now would like to invite Dr. Gopal, the research scientist of KMUTNB, to introduce our third keynote speaker, please.
Thank you, ma'am. Good morning to everyone. Our third keynote speaker is Dr. Sipong Potuleks from Toyota Motors Thailand Co. Limited. Dr. Sipong Potuleks is a senior executive in Thailand's automotive manufacturing sector and currently serves as a vice president of Toyota Motor Thailand Co. Limited, one of the country's leading automotive manufacturer and a key contributor to the regional mobility industry. He holds an impressive educational background from Thailand's premier institution with specialization in both engineering and business management, which has strongly shaped his professional journey. With a distinguished career spanning more than 30 years at Toyota Motor Thailand, Dr. Potuleks recognized as one of the company's prominent executives. As a vice president of the Toyota Thailand's Gateway plant, he provides strategic leadership to complex manufacturing operations, upholding Toyota's globally recognized production standards and administrative excellence, firmly guided by the enduring philosophy of Kaizen, thereby reinforcing the company's leadership in the regional automotive industry. Dr. Potuleks has been closely associated with Toyota's manufacturing initiatives in Thailand, including plant-level operational leadership and strategic initiatives that enhance supply chain resilience and workforce development. His professional profile is particularly unique due to its strong blend of deep technical industrial engineering expertise and high-level human resource development, enabling him effectively bridge technology, people, and performance. As a leader in industrial transformation, Dr. Fotulex brings deep insight into advanced manufacturing, sustainable production, and organizational innovation in the mobility industry. Today, he will share his expertise on industry trends, technological advancements, and the future of automotive manufacturing. I now wholeheartedly welcome Dr. Sripong Fotulex to deliver his keynote speech on transforming manufacturing beyond technology from lean system to intelligent mindset with AI and robotics. Over to you, sir.
First of all, I want to say thank you for Professor Dr. Thirawut Bunyasapon, Chairman of KMUTNB, and Professor Dr. Suchat Chiangsin, former President of North, and also the Director of KMUTNB Technology Parks. Thank you for inviting me to sharing my experience. Maybe I think this class mainly is talk about the technology, AI, and robots. In case of me, maybe I will sharing about the practice case. In case of the manufacturing, how we apply the technology to our manufacturing in the real practice. Before I talk about this, due to my experience mainly is manufacturing and includes some of the technology applied, and mainly is the leadership and mainly the people development. That's one really important for my experience. And also completely doctor degree as here. In that time, I learned about the technology, business environment, and how to apply the technology apply in the manufacturing side, especially industry of Thailand, more than 30 years. Our boss of guy before that one is like my teacher, teach me about many things in my experience. Start from today, I want to talk about the 4 topics related with the goals of the perspective of manufacturing and Thailand manufacturing. Also includes I will share practice of the Toyota and key takeaway before we return. And now of the days, next, okay. Today about technology is many things improve development and move to the future. And we can find almost of the technology is the findings. Many technology we difficult to selection, we difficult to apply, and we difficult to say that one is effective or not in the real practice. All of this one is mean we need to looking what is the circumstance of environments before we apply technology. Today I will sharing this one. Start from the global perspective. The path of the global manufacturing evolution. Sorry, back to the page. Okay. We can find the nature of the business is a move every 4 years, 5 years, or 10 years, almost it moved to the future. Until now, we already plan like a COVID situation. And also business also already moved from like a VUCA world to Bani world. And now maybe we call Love world, RUPT. This one is mean the condition of previous we cannot confirm still go on to the future or not. World change very fast. Who can understand on forecasting? What's it US thinking? What's it the Trump thinking when we want to act in the future? We cannot forecast that one. Example, someday you wake up, you found Trump talk something in the chatbot and also impact to our business in Thailand. I also don't know why linkage. Now, globally move very fast. And also we found the paradoxal of the thinking. Investment around the world, very sensitive in this time. Sometimes we investment in some technology, just only next year and next 2 years, that technology already expired. And we cannot use like a return on investment in our investments. Global economy overall look like different every time, but if we look back 100 years like a normal, I think the both business and technology same like that. If we look at the trend current and look back the previous, we found the trend of the economy look like a course, but the incline in the future, I'm not sure become to zero or not. That's one is the current important for the business. If we look at in case of the industrial, next. Industrial also, we cannot say we can keep this condition in the future or not. If we look at the business linkage with the industrial also technology move together with business from 1.0 to 2.0 now, and we also don't sure anymore in the future. In this case, if we use the technology now, it means in the future also we need to finding what is the next object technology. Next. And the implement evolution of the industrial, we also found that in the research of the technology implement, business would like to transform and use the technology. And we found the real business when we want to transform to the future, we found 30% cannot move to the future. 40% can move but not effective. Only 30% remain, it can survive to the future. It means the technology itself and business itself needs to think more about this. What technology we need to apply, link it with the business. Next. In terms of business in Thailand, yes. Okay. When we zoom in our country level, we also found Thailand also impact to business and technology. We slow economic growth, and also we impact. It's come from rough world, RUPT. We try to survive in this situation, and if deal down in some sector like steel or the textile, we also can find that the industrial maybe cannot have like a hopeless in the future. Industrial is collapse. Industrial is cannot survive. It means the business itself or technology or thinking way of the leader in that portion. Next. Zoom in the automotive industrial. Frankly speaking, it's the directly impact in this period because the high technology adopt. We cannot say high technology is make us not survive or survive. We must think about in the detail. Why same technology, some country, some industrial can survive? Same technology, some country, some industrial not survive. Especially in Thailand, we can find now Chinese brand come to Thailand and we talk very strong. Some technology, some BEV, but together it's some industrial in Thailand, like a Korean brand, Japanese brand. We are also finding that one cannot have opportunity in the future. It means the technology itself and business itself, we cannot say this is a good opportunity or risk for that business. Some business try to transform like Subaru or Suzuki, make the decision to move the plant from the Thailand, use only imports to Thailand, make the market in Thailand. Every country, every business, every technology to finding how to survive. Next. I cannot say which one is the real answer and correct answer. I just want to share about some portion of thinking way of the Toyota. Toyota also, we have many kind of business around the world. Currents, next. Okay. Currents, we produce our business in Japan nearly 100 years, and in Thailand more than 60 years. We have product in Thailand more than 700,000 units. We export to many countries, more than 180 countries around the world. In manufacturing plant, we have the 3 plants in Thailand. We have many technology implement in our manufacturing. We have the technical center in Thailand, engineer more than 2,000 members. Toyota Motor Asia Pacific. That's when also we learning about the technology to apply in manufacturing, also include in the products. We have the robot in our manufacturing site, more than 1,500 units. We have the high technology for robot for stamping, for painting, for welding, assembly, also include the technology for the logistics. If we look at here and we get some of the data from the eyesight, maybe thinking Toyota also prefer the technology first. But actually, I want to share you, our thinking way not same like that directly. We think something we are the customer thinking way, and also we try to use a customer thinking way to prove our process and prove our design. After that, we fulfill the technology later. Under this concept, you can look at many situations around the world, and also our Toyota business, like crisis of the hamburger, floods in Thailand, also last crisis like a COVID. And in this time also technology impacts. We still go on under this concept. I will share you what concept we use for when we respond for customer. Until now, we still go on in the world, allow the 10 million units sold in the world. Next. Next. Main of the thinking way for the response for customer, we come back to our original. Original of the Toyota, we try to think about the first thing maybe when we start the business, automotive loom, we think about the family issue. And after that, we grow the thinking way about the automotive industry in Japan, and also extend to about the commitment about the people. And now we also the response to the future. This one come from the like a root or the value, real value of the Toyota thinking way. We try to do many things, respond about the people thinking. Some words, if we try to explore to our member, to the social, is we try to produce the happiness for all. This is the concept last 5 years. We now still go on to the future. We think if we want to transform to the future, under the produce happiness for all, we can input some technology to fulfill in this condition. Next. I will explain some the thinking way. You can see if we look at our customer or the people, always customer needs never stop. Every time, every situation, every crisis, our customer start to change first. After that, we just hearing, we just understand feeling of the customer. We try to change our product and process, follow customer thinkings. Some of the example, you can see now we try to approach the multi-pathway concept and movement system. Multi-pathway is mean we understand our customer around the world more than 10 million units we sold. Our customer think the difference. How we make the product and process support all of the customer. We cannot say ICE vehicle can support. We cannot say battery EV can support. We cannot say hybrid can support. We must say every customer we must support. So multi-pathway concept is mean to hearing and respond all of customer. Also, when we want to prove some technology, we cannot directly to implement the technology. Example, the lower portion, that's one is the woven system. We want to testing future technology with the real people, real customer. In that time, we cannot do by ourselves. We also use like a partnership to think and to test together. Sometimes we call that one like a playground or the sandbox to testing. At the woven system, together with like a Daikin, Daito, or Nissin, we try to use all of the real people in that area to utilize the technology. And also we can hearing many things for real practice. We can fulfill for design, develop technology in the future. Under this process, we will bring that one like a customer requirement, and we feel technology later understand the real customer want. We feel in the like a vehicle more autonomous, more connecting more in our products and process. Next. Underthinking next. Underthinking this way, you can see the lower portion. That is the real customer in North America, China, Europe, also including the Asia. You can see real demand of a customer, different area, different requirements. So this is the big answer why we cannot make only one product around the world. We just make many products around the world, like a BEV, BHEV, CNG, also include like a hydrogen. The technology itself can help us to develop our product to respond our customer. In case of marketing side also, when we want to communicate our product with the customer, needs many technology to connect with our customer. Next. Some of the practice I will share you. Next. This one is some of the practice. Real customer want the vehicle, want the product. Sometimes we call mobility. Mobility is mean move the car, move the service to our customer. But if we look at the current or the conventional way, when we design the process, example, this one for logistics, we just think about how to supply parts to manufacturing and delivery the vehicle to our customer. When we talk about the supply chain or delivery logistics, we talk about transportation, mill run, storage, also flow together in the plant site and move to the future. When we understand the technology like AMR, forklift, or some technology transportation, we fill in. That's what we call technology. But the real thinking way of the Toyota, we talk about if we want to serve our customer demand or requirements, what is the real thinking way? We must come back to customer needs and redesign process again. The customer want our car, not want about our system of logistics. It means we need to design our logistics only necessary. Sometimes we have many words to call about our logistic operation like a non-value or the muda. However, when we want to design this one, what is the technology can support? We found that not only pure technology, we can apply some technology to support about logistics. The simple technology like move the parts, we call karakuri. Very simple. Some parts supply from the A location to B location like use the gravity of the world. That's one very simple technology. It makes us to improve logistic operation. It means when we want to investment, you can see not pure investment to that system. Just focus investment for customer only. The second example is inspection. Next. Sorry, back. Okay. Sorry, quality. Okay. The customer want the vehicle together with the quality. When we talk about the quality, maybe many techniques or technology to inspection the car. If we have the investment, maybe we think about how we can implement technology for inspection. But we turn back to a conventional way. When we talk about the inspection quality, we provide inspector people. We provide the condition of inspection. We provide information. And also we include some like a working environment for our operator. When we have the technology, maybe we fulfill like a robot detachment for inspection. That's one is the normal thinking. But back to the basic, our Toyota thinking. We think about the customer first. Customer want quality, but she don't want about that process. How you can decide based on yourselves. Toyota come back and be design thinking again. If we want to ensure the quality, how can we looking the products? The technology itself, we can use like an AI, we can use the camera to looking the product, to compare and judgment by the AI. So that's when we apply the AI and camera to vehicle inspection, repair the conventional way. Next. Next. Under follow this concept, not only this one, we have around the world we implement this concept to our Toyota group, not only in design area, technical area, manufacturing area, also include the marketing area. We can respond our customer more than 10 million area around the world. Next. The finalists, I want to, next. The finally, I want to conclusion. When we talk about the technology, we don't talk directly with technology. We try to turn back, talk about the customer first. What's the requirement of the customer? The next, we think about the process, how to make the car. That's one is the second step. The third, we try to implement the technology to fulfill and support to respond our customer. If the technology itself cannot respond, it means we cannot select that technology until that technology can respond the process, and that process respond for our customer. Back again, when we talk about business and love world, we cannot say which one is the answer. I think the business and each business and each environment is different. Each leader must look back to his business, must understand the technology and select. Transformation look like a simple word, but the real practice, how the leader move business, follow customer requirement under technology. Thank you very much. Thank you. Any question, please? Maybe not related with the presentation is okay.
Yes, I have a question here. When you mean this success, you have to develop new structure, new products, and how work Toyota? They work with research institution also in Thailand, or you have to do it with Japan?
Okay. Okay.
You need.
Okay. Before answer about, I want to clearly about the customer requirement first. Maybe due to we have the markets around the world. It means when we want to hearing the customer requirement, cannot hearing only in Japan. We must hearing around the world. It means from the China, from the US, from the Europe. Our technical center now around the world. We have made around 4 or 5 technical center together with the designer and researcher, more than 100,000 designer. In Japan, like mainly, nearly about 60,000. Second, it is in the US. The third in the China. In Thailand also we have Toyota Motor Asia Pacific. We have the designer and researcher around 2,000 members in here. Yes, we believe that that country, that member, he really understand the voice of the customer. So it's been our designer, variety of the people in here to design and development. And when we make the concept, if the separate design, maybe we lost our competitiveness. So we have like a network to sharing around the world, relates with the designer. Sometimes you can find why design in the US can use some common design in the Asia or in Japan. We try to sharing. And also in Japan also we try to sharing. But now the time is we found 100,000 designer and researcher not enough for the future. We try to collaborate with our partnership. You can see sometimes we collaborate with the BYD, Chang'an, Honda, Isuzu, many look like a friend for like the world of the technology on research. We are the friend. We can sharing the design. That's one together. And the one thing is who can apply your customer. Maybe I think every brand looking his customer at a different point. Toyota also, when we looking customer, you can see many research, maybe same paper, but why designer when read the paper apply to the product, it different. It means that product includes customer requirements and process. After that, become to like a product. That's one is the point why you can see many product is different in the world.
Thank you for the presentation. One question, when I look at your multi-pathway approach, I see vehicles, I see hydrogen vehicles. What does Toyota do in terms of infrastructure?
Okay.
You need charging stations, stations. So is there for this technology as well?
Okay. Before answer hydrogen, I turn back, thinking way again. Thinking way, we try to implement the product also with all mobility together with technology based on customer requirement. Example, hybrid. We implement hybrid technology and start Prius. If you remember, around 40 years ago. In that time, challenge guy is being a designer, try to develop the products. You know, what is the final? In that year, he respond, me become designer, cannot sell the car. But our philosophy is, we think for the future. We have many testing before, product, infrastructure. Your question is hydrogen. We also believe for our customer want clean energy, want to keep like an environment issue. That's product very good for customer, for social, for environment in the future. So infrastructure, now in Japan, we already start last 15 years, but still not become to like a mass production. In China also, we collaborate with the company in China make. For Thailand, we also start 5 years. Our director, Maeda Sang, come to here together with our president, Sato Sang, directly connect to the Thailand. Because we believe if we want to support our customer, we cannot do by ourselves. We looking for the partnership to install infrastructure, to install like a farm, to provide like a hydrogen. And also we respond to make like an ecosystem and fuel some product. I also and our Toyota believe next 10 years or next 20 years, hydrogen is the one solution for our customer. Not 100%. We also believe no way customer 100% believe in something. A variety of customer, maybe 20% in the BEV, 30% in the HEV, some percent in the hydrogen. I think around the world maybe like that. So we try to install here. Maybe next 10 years we can answer how many infrastructure in Thailand. But now under testing. In our plant, in the Banpo plant in the future also, we implement some station like a playground to testing, to learning.
Sir, one more.
Thank you. Okay. Yes.
Yeah, this is fuel cell stuff. Well, which way you want to go?
Now we maybe you understand too, but the real research many more than 10, more than 10. As I answer based on customer, if customer provide on this like a fuel cells, maybe this one will grow more. If provide hydrogen, maybe hydrogen. If we looking the industrial in China, we understand now trend of the hydrogen more increase, especially in case of the mass transportation, because we can fix station, we can ensure fill in and empty hydrogen and return back to fill in again. That's when I also sharing the data in China. Maybe the trend is really good for hydrogen.
I see.
And also we hope in the future fuel cell, because under current technology, fuel cell also very simple in the future.
That's great.
But now we just waiting how we come to the mass. almost it's been an ecosystem. Now, if we looking our business based on ecosystem, we cannot sell only car. We must talk about aftermarket. We must talk about the second-hand car. Yes. Also, we must talk about how to reuse some parts if we don't use in the future. That's what we call ecosystem. We try to think about that.
Thank you.
Thank you.
Sir, yeah, very informative talk from you. And my question is very general. So most of the car companies or most of the manufacturers, car manufacturers, or go with carbon neutrality or sustainable mobility, right? So as you are leading Toyota Thailand, my question is, I'm the material researcher. So my question is about how the Toyota is related with sustainable material research, which can meet UN Sustainable Development Goals.
Okay. For researcher or for development?
Yes.
After the condition of customer change, variety of the product, one thing we found the workloads. Every area, example, start from designer. Designer cannot research or develop only ICE, much research about hydrogen, much research about BEV, hybrids. It means that very high workloads. Also in the material, we also need and require to move our product to the future. We also try to increase. I just hearing some Euro in percent of the circular economy or something very high level.
Yeah.
We also limitation of a designer and development. So in this point, now we change the way to work. We still keep much responsible to our customer, but the way it is like a connection. We need to connect with our partnership. Now we found many development area, from supplier, from our a previous maybe competitor brand. We collaborate together to development. We hope this way can support our customer, not only Toyota customer, the world of the customer. That's when we try to collaborate. Also, university also, we try to connecting to make the clear and sharing research. Yes. In Thailand, I think now, due to when we talk about, we need to increase many jobs under concept of multi-pathway. We need to priority which one is the first priority from now. Okay. Maybe now we focus on how to move or transfer or transform some business to survive. The first. The second also, in this survive and many variety of customer, how to develop in the future. We don't develop in the future. We try to priority to research in the future.
Any strategy from Toyota Thailand for the extension of material research from the company to universities?
Yes. Now you can feeling our director of the Asia, Maeda-san, try to catch up together with the designer from the Japan to Thailand, and also join with the CP, many company in Thailand, and for the university now under study with university with the measure we want to connect. Maybe I think a kind of many university in Thailand also have the collaboration. Sometimes we don't need to select or pick some university. We need to sharing together. Yes.
Thank
Maybe
you.
just start. Start.
Okay. Thank you.
Okay. Okay, thank you very much.
Thank you, Doctor, for such a wonderful talk. I know that many attendees, including myself, left with a greater appreciation for the topic and its importance. I am grateful to have the opportunity to hear from you and learn from your wealth of knowledge and experience. Thank you once again.
Thank you very much for our three keynote speakers and also Dr. Kapal and Dr. Siripong Pothalak. And for this event, I would like to invite Professor Dr. Theravut Bunyasopon, the chairman of KMUTNB Council Committee, along with Assistant Professor Prisha Ong Ari, the Vice President for Planning and Organizational Development, the former President and the former of KMUTNB Techno Park, to join us on the stage to present the mementos for our distinguished speakers, please. On the list, we have the 12 distinguished speakers. First, I now would like to invite Dr. Siripong Pothalak from Toyota Motor Thailand Company Limited. Second one, may I invite Professor Dr. in Habilitation Lothar Kroll from Chemnitz University of Technology, Germany. On the wave, sir. Next, we would like to invite Professor Dr. Habilitation Stefan Fischer from Dresden University of Technology, Germany, please. Next, we would like to invite Professor Dr. Ahmed Artif Mohammad Fosi from University Technology Malaysia to receive the mementos, please. Next, I would like to invite Professor Dr. Ing Thomas von Anwerth from Chemnitz University of Technology, Germany, please. May I invite Professor Dr. Gianariello Conaberti from Dresden University of Technology, Germany, please. Next, may I invite Professor Dr. Ing Jonas Hansel from Chemnitz University of Technology, Germany. May I invite Professor Dr. Ing Sebastian Strauss from University of Applied Sciences, Seattle in Germany. Next, we would like to invite Professor Dr. Hiroshi Fukuda from Chitose Institute of Science and Technology, Japan. May I now invite Assistant Professor Nopadon Pachun from IRAP team, KMUTNB. Next, may I invite Mr. Maximilian Crow from Deakin University, Australia, to receive the memento, please. Last, may I invite Mr. Sansuke Yoshihara from Chitose Institute of Science and Technology, Japan, to receive the memento, please. Thank you very much again. I now cordially invite Dr. Satich, the research scientist of KMUTNB and the co-chair of this conference, for delivering the vote of thanks, please.
On behalf of all the committee members of RAM 26, I would like to express my sincere thanks to our chairman, sir, to our respected president, to our respected honorary chair of this conference, Professor Dr. Inhabel Suchat Sengsin, sir, respected chairman of this conference, Associate Professor Dr. Sanjay Mavenkararangappa, and other distinguished KMUTNB administrators. I extend my wholehearted thanks to all the keynote speakers and the distinguished speakers for delivering a talk at RAM 26. And I'm highly thankful to all the participants from various countries who are registered for this conference. And I wish to thank the team of Techno Park, ICC, AED, TGGS, and STRI at this juncture for providing their constant support to make this event possible. Also, I would like to express my gratitude and thanks to all the advisory committee and scientific committee of this conference to select the papers, to present their papers in this conference. And I would also like to thank all the organizing and technical committee members and our NCR team members for their support and involvement to make this event possible. And I would like to thank Dr. Pinoy and Hani for her unwavering support to make this event possible. Also, I would like to thank the Thailand Science Research and Innovation, TSRI, and National Science Research and Innovation Fund, NSRF, for the funding support. I hope this conference will be informative and all of you will enjoy all the sessions. So thank you one and all present here, and we expect your presence in all the future events of KMUTNB.
Thank you very much, Dr. Santish. For this part, we would like to ask the 12 distinguished speakers, 12 that just received the mementos on the stage for the group pictures, please. So with the side, and also our executive team of KMUTNB. For the executive team of KMUTNB and 12 distinguished speakers. So we will have the memorable pictures with the Ram 26. We will take the two lines on the stage. Short lunch break and join again at 12:15 p.m. for the special session. For special session 1, the German session will be held in this very room at 12:15. And for special session 2, the Japan-German Thai session will be held in the Vayu meeting room from 12:15 p.m. to 2:45 p.m. And for special session 3, the India and Thai session will be held in Vayu meeting room from 2:45 to 4 p.m. So thank you very much for your time and hope you all have a nice relaxing lunch and a wonderful day. Thank you very much. สวัสดีค่ะ